In this example of Turing machine, I'm going to show you how to produce 2's complement of a binary string. This is again an input-output Turing machine. So at the end, the machine should halt after converting the binary string to its equivalent 2's complement. And there we need not to consider a final state. So if the input is this 10110, for example, then the output should be 01010. Now one way of doing this is first of all converting the input string to its ones complement, then add 1 with that ones complement and we get 2's complement. And another way, the easier one, would be that if we understand the pattern of 2's complement of a binary string. So what happens if this is the string? We can just write down the 2's complement starting from the rightmost bit in the same way as it is in the input. That means if it is 0, write down 0 here. If it is 1, write down 1 here. And after you encounter the first one from the right hand side, then we need to complement each bit on the left. That means this 1 will now become 0, this 0 is now become 1, and this 1 is now become 0. So this is the 2's complement. Now if we are going to do it in the traditional approach by adding 1, by doing 1's complement and then by adding 1, we will get this. So the thing is that if you have something like this 1 1 1, then the 2's complement of this is going to be, we are going to write from the right hand side. So this 1 should be written as it is, and we have encountered the first one, so the rest of the things are going to be inverted. So let me give you one more example. So we have this 1 0 0. So the 2's complement of this is, we should write from the right. 0 is here, 0 is here, and we have encountered 1, 1 is written. Now everything is to be inverted. So this is the 2's complement of this string. So we will be using this for designing our Turing machine. Let's do that. So say our input given is this one 10110, 10110, and we are having this in our tab 10110, and we have blank spaces on either side, and the tab is infinite on either side. Now initially we are here. Now first of all we need to move towards right, and we need to encounter the blank space. Then we will be moving towards left by converting the bits. So if you are in Q0 and you are getting either of 0 and 1 or 1, you should move towards right unless and until you encounter a blank space. So if we are considering Z, now Z is actually 0 or 1. Okay, it can be either 0 or 1. So if this is the case, then we will keep the same state. We will keep the same thing and we will move towards right. So if you are in Q0, that means you are starting the machine and you have 1 here, what we will do, we will just move towards right. We will move here in Q0 in the same space. Again we are getting 0, we will be moving towards right. Again we are getting 1, we will be moving towards right. Again we are getting 1, we will be moving towards right. Now again we are getting 0, we will be moving towards right. Now we have encountered the blank space. That means we have traversed the whole string and we come to the space. So when we get blank space, now we should start moving left by changing the state. So Q1 is the left moving state. Now Q1 in Q0, in Q0, if we encounter a blank space, what we are doing, we are changing the state to Q1, writing the blank space on that cell. That means it remains same, and we start moving left. So in Q0, if we encounter blank space, what we are doing, We are just moving towards its left. So the head is moved here in Q1. Now in Q1 we are encountering a 0. Unless and until we encounter 1, the things are going to remain same from right hand side. I hope that you remember the law. So if in Q1 we get a 0 or 1, is going to remain, we get a 0, I'm sorry. If we encounter a 0 in Q1, what I need to do is to move left by keeping the 0 same. So in Q1 we are getting a 0, we are moving towards left, we are coming here in Q1. Now in Q1 if we get 1, that means this is the first one that we have encountered from the right hand side. So what I need to do is to change the state to Q2 to identify that we have encountered the first one from the right hand side. So in Q1 if we encounter 1, what I do, we are changing to Q2 and keeping the 1 same and moving left. So in Q1 we are changing it to Q2 and moving left. So in Q2 if we get 1, we need to flip, we need to change it to 0, and if in Q2 we get 0, we need to change it to 1 unless and until we encounter blank space on the left hand side. So now just go on changing the bits. So if it is Z, that means either 0 or 1. Just in Q2, I'm sorry, we need to separate it in this way. So if it is 0, we are changing it to 1 and moving left, and if it is 1, we are changing it to 0 and moving left. Now in this way, what will happen? We will change this to 0, we will change this to 1, and we will change this to 0. So Q1 after changing this, Q2 after changing this 0 will come here. Now in Q2 if you encounter a blank space, then the machine should halt. In Q2 we halt. That means everything is done. So here is the 2's complement of the input binary string. So here is the final Turing machine for the purpose of converting 2's complement of a binary string. So in the next lecture I will give you some more examples. Thank you very much.